In the realm of nuclear energy and waste disposal, a concept has emerged that seemingly offers a straightforward solution to a complex problem: shooting nuclear waste into space. At first glance, this idea appears to provide a convenient method for disposing of hazardous materials, suggesting that the vast emptiness of space could serve as a safe repository for Earth's nuclear remnants. However, upon closer examination, this notion unravels to reveal a reality that is not just flawed, but deeply problematic, with consequences that grow increasingly dire the more we scrutinize them. Understanding nuclear waste. Nuclear waste is a byproduct of nuclear processes, consisting of materials that are highly radioactive and pose significant health and environmental risks. This waste is categorized into three main levels. 1. Low-level nuclear waste. This category includes items that have been contaminated with radioactive materials, but the levels of radioactivity are relatively low. These items can include protective clothing, tools, and equipment used in nuclear facilities, as well as materials from medical facilities and research labs. Low-level waste typically contains short-lived radioactive isotopes and can often be safely disposed of in landfills designed for radioactive waste. However, some countries may require special disposal methods or treatment before disposal. 2. Intermediate-level nuclear waste. This category includes materials that are more radioactive than low-level waste and require more careful handling and storage. Intermediate-level waste is often generated from the maintenance and operation of nuclear reactors, as well as from decommissioning activities. This waste can include reactor components, ion exchange resins, and contaminated materials from reactor decommissioning. Intermediate-level waste is typically stored in specialized facilities, either near the site of generation or in centralized storage facilities. 3. High-level nuclear waste. This category includes spent nuclear fuel from nuclear reactors. Spent fuel is highly radioactive and contains a mix of fission products, plutonium, and other transuranic elements. High-level waste is generated during the operation of nuclear reactors and must be safely stored for thousands of years to allow the radioactive isotopes to decay to safe levels. Currently, most high-level waste is stored in interim storage facilities at nuclear power plants, but long-term disposal solutions are still being developed in many countries. It's important to note that the categorization of nuclear waste can vary between countries, and some countries may have additional categories or subcategories based on the specific types of waste generated. Additionally, the management and disposal of nuclear waste are complex issues that require careful planning and consideration of safety and environmental impact. The proposal to shoot nuclear waste into space as a disposal method has garnered attention for its apparent simplicity and the perception that space provides an infinite void where waste can be safely disposed of. However, this proposal is not without significant challenges and potential risks that must be carefully considered. Advantages of shooting waste into space. Space is vast and empty. Space is vast and seemingly empty, making it appear to be an ideal location to dispose of nuclear waste without impacting life on Earth. Permanent disposal. Sending waste into space could potentially provide a permanent disposal solution, as it would be unlikely to return to Earth. Challenges and risks. Cost. One of the most significant challenges is the cost associated with sending waste into space. Launching payloads into space is extremely expensive, with costs ranging from thousands to millions of dollars per kilogram. The cost of sending all high-level nuclear waste into space would amount to billions of dollars annually, significantly increasing the cost of nuclear energy production. Logistical challenges. The current infrastructure for space launches is not equipped to handle the volume of nuclear waste generated. Repurposing existing rockets would not be sufficient for transporting all the waste, let alone the hundreds of thousands of tons in temporary storage. Space debris. Launching nuclear waste into space would exacerbate the problem of space debris. This debris could pose a threat to satellites and spacecraft, increasing the risk of collisions and creating additional space junk. Safety concerns. Rocket failures are not uncommon, and a failed launch carrying high-level radioactive waste could result in a significant environmental catastrophe. The dispersal of radioactive material into the atmosphere could have far-reaching consequences for human health and the environment. International cooperation. Coordinating the disposal of nuclear waste into space would require international cooperation and agreement on regulatory frameworks. This could be challenging given the complexity of international relations and differing national interests. Alternative methods of nuclear waste disposal exist that offer more practical and sustainable solutions compared to shooting waste into space. These methods focus on containment, isolation, and, where possible, recycling of nuclear waste. 1. Deep underground burial. One of the most widely accepted methods for disposing of high-level nuclear waste is deep geological disposal. This involves burying the waste deep underground in stable geological formations, such as deep rock formations or salt deposits. The idea is to isolate the waste from the environment for thousands of years until its radioactivity has decayed to safe levels. 2. Reprocessing. Reprocessing involves extracting usable materials, such as plutonium and uranium, from spent nuclear fuel. These materials can then be reused as fuel in nuclear reactors. Reprocessing reduces the volume of waste that needs to be disposed of and can make nuclear energy more sustainable by recycling fuel. 3. Advanced reactor designs. Some advanced reactor designs, such as fast reactors and molten salt reactors, can use nuclear waste as fuel. These reactors can potentially consume existing nuclear waste while generating electricity, reducing the amount of waste that needs to be disposed of. 4. Improved storage methods. In addition to disposal methods, improving the storage of nuclear waste at nuclear facilities can help manage the waste more effectively. This includes using robust containers and storage facilities that can withstand natural disasters and human error. It is crucial to find a sustainable solution to nuclear waste disposal that minimizes environmental impact and ensures the safety of future generations. By exploring alternative disposal methods, reprocessing, and advanced reactor designs, we can work towards a more sustainable nuclear energy future. In conclusion, the proposal to shoot nuclear waste into space, while initially appealing, presents significant challenges and risks that make it an impractical and potentially dangerous solution. Alternative methods of disposal, such as deep underground burial and reprocessing, offer more viable and sustainable options for managing nuclear waste. As we continue to explore these alternative methods and advance nuclear waste management technologies, it is essential to prioritize safety, environmental protection, and long-term sustainability. By doing so, we can ensure that we manage nuclear waste responsibly and protect the health and well-being of both current and future generations. Subscribe now to stay updated with our latest videos and continue learning about the fascinating world of science and technology.